Okay, this is the P2 paper from January 2024. It's question number 4. This question sort of breaks down into two parts. This first part is looking at curve sketching and sketching an exponential function here, but then the second part is using the trapezium rule to find an estimate for this integral here, and then playing around with the trapezium rule for the last part. Last part's quite tricky actually, but let's focus on the first part at least. It says, can we sketch the equation, sketch the curve with the equation y equals a to the minus x plus 4. It tells me that a is greater than 1, and it also tells me that on it I want to label the point of intersection with the y-axis and the equation the asymptote. Okay, let's find the space to be able to do this one. So let's draw out a set of axes, and then let's talk through how we're going to do this question. So the x-axis and the y-axis. So there is an assumption then that we know what a to the x looks like. A to the x, I would imagine you know what e to the x looks like. So a to the x is that same family of curves where we're going to have that it hits the axis here at 0, 1, and there'll be an asymptote here on the x-axis. That's a to the x. I haven't got a to the x, I've got a to the minus x. But a to the minus x is just a reflection in the y-axis, so is basically going to do that. So let's get rid of the a to the x, that's in the way. A to the minus x then looks like the graph that I've just drawn on the screen. And then what we actually want, our one, is going to be y equals a to the minus x plus 4. So if it's a to the minus x plus 4, then the whole graph is going to move up 4 units. So if the graph moves up 4 units, when the graph moves up 4 units, this won't be at 0, 1 anymore. It will be, let's just change it, it's going to be at 0, 5 now. So the point where it hits the y-axis will be at 0, 5. And then remember we had an asymptote, I'll just put it on and I'll move it to the right place. We had an asymptote that was down here on the x-axis. That's moved up by 4 units as well. So if that's moved up by 4 units, then the asymptote is y equals 4. So now I've done all that, let's just tidy it up and bring that a little bit down for the actual answer there. So part A, can we sketch the graph? Yes, I've done that. Can I find the coordinates of the intersection with the y-axis? And can I find the equation of the asymptote to the curve? I've done both of those. So part B says, can we find an approximate value for the integral of this if this is the table of values for that function, 3 to the minus half x plus 4. Just check that these limits are these limits here. Yet nothing different that I need to do. It is just a standard application of the trapezium rule. So let's get going with that and explain what the trapezium rule is. So the trapezium rule says, what have we got? We want the integral between 8.5 and minus 4 of this rather complicated looking function, 3 to the minus half x plus 4 dx. And what we can say is that the trapezium rule says it's d over 2. It's the first, let's go back and say what those ones are. Sorry, so this is y0, y1, y2, y3, y4, and in this case, y5 is the last value there. So trapezium rule says y1 and y5, and then 2 lots of those ones. But let's do that where my answer is. So it's y0 plus y5 plus 2 lots of, in this case, y1, 2, 3, and 4. Okay, let's substitute everything in. D, what's D? D is the gap here each time. Take the easiest one to look at, which is that one there, because it's constant gap. It's 2.5, isn't it? So if it's 2.5 there, we're going to have 2.5 over 2, and then you're just subbing everything in. So just take your time copying this out. 4.009 two lots of the others, which were 6.280, 4.577, 4.146, and 4.037. Okay, and then, yeah, it's important to copy it out, but it's also important to stick that into the calculator properly. I've already done that. It came out for me to be 68.86125, and the question said, can we have it to two significant figures? So two significant figures is 69. Okay, let's have a look at this C then, and these can get quite complicated with now applying the trapezium rule and trying to play around with it a little bit. So I'm just going to leave this on the screen a second because it's easier to have it with the question for C part 1 here. Right, they want me to find that, but I can't find that. The only thing I can find is that there, that's 69. So what I need to do is, if they're asking me for this answer, I need to adapt that in some way to get it. This one's not too bad. I'll do it here and then I'll explain it to the examiner here. If I want the integral of 8.5 minus 4 of 3 to the minus half x without that plus 4, what I can do is I can say, well, that's the same as what I know, which is that. That's the only thing I can do. But how can I make that look like the left-hand side then? Well, I can just take away 4, can't I? So if I take away 4, then that does become the right thing. So now here, I can split this function up into the integral. I'm going to do integral of this bit minus integral of this bit. Let's explain that to the examiner and then get on with actually doing the question here. So let me just see if I can get rid of that. So what we're going to say, put up there, and then we'll explain what we're doing. So just writing out what I said, but for the examiner's benefit here. So C part 1, we're saying then that the integral 8.5 minus 4 of 3 to the minus a half x dx is actually equal to that, and then that breaks down to be equal to the integral of the function that we had previously. That, I know that is, what was it, 69, but minus the integral between 8.5 and minus 4 of 4 dx. So if I can work out this bit, I can then just take that away from 69 in a minute. So it's 69 minus, well, the integral of 4 is 4x, isn't it? So it's 4x between 8.5 and minus 4. So simply, goodness sake, sorry, simply sub in the values, just say I've done that previously, that works out to be 50, that part, and so then 69 minus 50 gives me an answer of 19 for this first part here. Now, let's have a look at this second part, which again, it's not that easy to see, but first part's all right, because this first part here is actually just our 69. That bit there, if you just look slightly higher up on the screen, that's exactly the same thing. These are just the same as each other. But let's have a look at this second part then and say, well, what's different? Well, first of all, I've got half x rather than minus half x. Well, we know what that does because we did that in that sketch before. Sorry, in that sketch there. We know that if I had half x rather than minus half x, just be a line going the other way. So it's just a reflection in this line here. But then look what also happens is instead of doing it between 8.5 and minus 4, we're doing it between 4 and minus 8.5. We're just going to get the same area. It's just going to be a symmetrical version of it. So that's 69 and that's 69. Let's see if we can explain that for the examiner then. It might help you when I try and do it in a bit more detail for the examiner. So this is C part 2. So we've got the integral 8.5 minus 4, say this is the 69, 3 to the minus half x plus 4 dx plus, but then what have we done? We've swapped the limits round there, which is the equivalent of flipping it about the x-axis, but we've also then flipped the graph around about the x-axis as well. So in effect, we've done nothing different here. So this is going to give me 69 plus 69, and then whatever that works out to be, 138. Let's just explain this bit for the examiner. I'm not sure how many marks this is worth. It might be that we, let's have a look. Yeah, so we don't need to explain. This is more just to explain it to you guys here then. So what we're saying is, so this is just an explanation for you guys. This bit would be, if I had my graph, I'm doing something like that between -4 and 8.5, and the other part, I've flipped the graph round, but I've also flipped the area around, -8.5 and 4 here. So this area there and this area there are both the same as each other. They're both 69. Okay, but I'd say we don't need that for the examiner. I've just done that to explain that to you guys, but the examiner will just be happy that we've managed to get the two parts to that. So not easy, that one, not easy. Some of those can be a little bit tricky, but hopefully with the explanation with the diagram, that makes sense to everyone.